Okay, students can go over practice DCAS version 2. Again, the way you use this is go and find problems that you're not sure of and just fast forward to those problems and look at those problems. Otherwise, you can just check your answers as you go along for the other ones. And only if you miss, go ahead and check. Or if I've written down other information that you didn't know vocab-wise, to go ahead and add that to your page as well. All right, here we go. So the company charges $35 per person. When you see per person or per something, that's a dead giveaway that is the slope. Okay, remember y equals mx plus b. M is your slope. So it's going to be y equals 35x if that's what they're using, yes, or they're using x. And $245 for the tour guide. The $245 for the tour guide, that's a one-time fee. So that's your y-intercept. Okay, so there's your equation right there. And we want it in function notation, c of x, and that's why it's written as c of x instead of y. Remember, that's the same thing. Okay. C is the name of the function, and x is called the independent variable. Okay, vocab-wise. All right, the expression that right there is equivalent to. So here, I want to see if you can distribute correctly. And then I should go ahead and do that, and I get 3x plus 12 there. I get minus 2x, so I'm going to line that up under like terms, and I get minus 7, line that up under like terms, and add straight down, and I get x plus 5. And there's my answer. Okay. The function is defined by that. Find the value of k of 3. K of 3, or negative 3, that is. That's the x value. Okay, we know that from right here. See, this is k of x. So that means plug negative 3 in for x. So now it's order of operations, PEMDAS. Remember, I substitute in, I put parentheses around it. Okay, so PEMDAS going down because we're not solving for an equation. We're just simplifying terms. When you simplify terms, you go down. So we do exponents first here. So that's 9. Negative 3 squared is 9 times 2 is 18. And then I have multiplication, negative 5 times negative 3 is positive 15. And then I have plus 3. So it's 33 plus 3 is 36. And there's my answer. Okay, 6 over here. What's the solution to this? Okay, so again, we distribute. Get 3x minus 24 plus 4x, combine like terms. 7x minus 24 equals the 8x plus 4. We want to take the smaller variable over to the bigger side, so we're going to subtract the 7x across, which means the constant's going the other way. Subtract the 4 across. And I get x equals negative 28 right there. Number 8, when written in standard form, remember standard form means highest degree down. You look at each term's degree and put in order from highest degree down. So one thing I can look at, is there any of them that aren't in standard form? Yes. Number 4 is not in standard form. Okay. If we look why, this 2 is the highest degree. It should be out front, and they should have combined those like terms both. So there's 2 errors there, and the constant should be at the end. So you can wipe that out immediately. Okay, the product, so that means multiply. 2x minus 5 is in standard form. Notice the 3 plus x is non-standard form, so I'm going to rewrite it as x plus 3 in standard form. And then go ahead and multiply. You can use the vertical method, or you can just draw your error like we did in multi-binomials together. It doesn't matter, you're going to get the same answer. So it's minus 15, and 3 times 2x is 6x. X times negative 5 is negative 5x, and x times 2x is 2x squared. We have our like terms right there, and just add straight down. And we get that right there, and you're looking for that answer. Right there. Standard form. Highest degree down, degree 2. Remember, that's called the quadratic term. Degree 1 is the linear term, and degree 0 is the constant term. Reviewing your vocabulary, okay? Which one is not a function? Remember, in order for it not to be a function, there can be no repeat, or in order to be a function, there cannot be any repeat x's. So we're looking for one that's not a function. We're going to look for repeat x's. And the only one that has repeat x's is right there. 6 goes to 10 and 6 goes to 12. Repeat x, repeat of 6. None of these others repeat. So that is your answer right there. Which product is equivalent to that right there? So if I look at the first term times the first term on all these, I'm going to get 4x squared. So that didn't help me at all. Okay, that's 4x squared. If I multiply the last two terms together, I'm going to get the negative 27. So that didn't help me at all. So what it comes down to is when I multiply the outer numbers and the inner numbers and add them together, I need to get a negative 3x. So notice here I get negative 12x and I have a plus 9x. And what's 9 minus 12x? Negative 3x. So there's my answer right there. Remember, if you did the Carlson method with the factoring, you have your two smiley faces and you'd see it right there to quickly check. Okay, and if you did that for any of these other ones, it would not work out. You would not get the negative 3x. The value of Tony's investments, $11.40 on January 1st. On this date, 3 years later, his investment's worth this. So at date zero, it's $11.40. At 3 years later, it's $18.24. Because the average rate of change, whenever you see the word average rate of change, you need to automatically be thinking slope. So I find the slope between the 2 points. You should know slope equals change in y over change in x. You do this 6th grade, 7th grade, or 7th grade and 8th grade, and now again in 9th grade. Okay, so the long way of writing that is y sub 2 minus the y sub 1 all over x sub 2 minus x sub 1. Okay, so I have 1824 minus 1140. So I'm going that way there. I have to go the same way there. 3 minus 0. So I get, let's see, not 700, it's going to be 600. Let's see, 4. Okay, 12 is going to be 8. And 7, 6. 684 divided by 3. That's going to be divide that, and I get 228. Okay, so it's 228 per year because this is 3 years later. So that's $228 per year. Now notice they don't have it. They want it as $19 per what? So the question is 228 divided by what will give me the 19? So I get it down to that. Well, that's going to be per month. If I divide that by 12, I take that and divide by 12, I'm going to get 19. And what does that 12 represent? Each month. So $19 per month. So you have to look at what they wanted in as well. Okay, so 2 sort of steps with that one. Number 7, ice cream shop sells ice cream cones. C, and milkshakes. M, each ice cream cone costs $1.50. So $1.50 times C, and each milkshake $2. So $2 times M, I mean, for milkshake. Let's rewrite that. Donna has $19 to spend. So the most she can spend is 19, less than or equal to 19. If you want to put the 0, 0, you can't. Dot 0, 0, you can. If she must buy 5 ice cream cones, okay, so she has to buy 5. That's not an option. So that's going to be $1.50 times 5 plus $2 or 2M is less than or equal to 19. And so that's one we're looking for, which right here is number 2. The number 1 says greater than or equal to, so they're checking to see if you understand the difference between your symbols. Okay, which expression for 9 results in a rational number? Remember, a rational number can be written as a fraction. Irrational numbers can't be written as a fraction, and thus they are mostly radicals. Remember, anything that's a radical that is not a perfect square, that's an irrational number. So if I go through, I go x plus y. If I add this plus this, I'm still going to be left with that 3 root 2. I can't combine those. So I still have a radical in the answer. So that's not rational, it's irrational. How about y minus w? If I do y minus w, so you look, oh, okay, I have a square root of 2 and a square root of 8. I can't do anything like that. Well, remember that square root of 8 breaks down more. So I'd have 3 root 2 minus 2 times, and root 8 breaks down to root 4 times root 2. So I'd have 3 root 2 minus, remember that right there is 2. 2 times 2 is 4 root 2. And then 3 root 2 minus 4 root 2 is negative 1 root 2. And so I am still left with a radical in a problem. So therefore, that's not it. W times y. 3 root 2 times 2 root 8. I don't have to simplify the root. I could go ahead and just multiply those two together and get 6. Multiply the two radicals together and I get root 16. And we know the square root of 16 is 4. So now you can see my answer is 24, which is a rational number. So they're going to ask you this with radicals and rational numbers. It's usually always going to be when you multiply them together that you'll end up with a rational number as opposed to an irrational. If you add, subtract, or divide, you will usually always end up with a irrational number if you have a irrational number, meaning a radical in the problem to begin with. So just know that. You should immediately be looking for the multiplication. All right, here we have these two functions, the f function and the g function right there. 4 statements about this system are written below. Okay, does the f of 4 equal the g of 4? So if I plug 4 into there and plug 4 into there for that x, do I get the same number? The answer would be no, because here I'm going to get a fraction, because 2/3 does not cancel with 4 nicely. So I'm going to get some type of fraction, whereas here I plug in 1/4 of 4 is 1 plus 1 is 2. So that's false. Okay, when x equals 12, does the two functions equal? So now I'm plugging in 12 into there. 12 divided by 4 is 3 plus 1 is 4. 12 into there. 12 divided by 3 is 4 times 2 is 8. And I got 8 minus 4 is 4. Notice they are the same. So that's true. The graphs of f of x and g of x intersect at 12, 4. Well, that's going to be true because if x is 12, notice we got 4 for both of them. So they do intersect at 12, 4. So that's true. And then here, this is switching the x and y and putting 4, 12. That's false. Okay, you're not going to get the same. When you plug in 4, we already plugged that in. We got 2 and 1 and a fraction and another. So 2 and 3 are true right there. In the DCAS, it may not have it like this. It may say select all that apply, and then have those things and select all that apply, and you do it. All right, which sketch represents the polynomial function? Well, remember, this is written in factored form. What do you do when it's written in factored form? You set each factor equal to 0 and solve. So you got x equals 0, that's already done. You got x plus 6 equals 0, and you have x plus 3 equals 0. So here we get x equals -6, and here we get x equals -3, and this one we already had x equals 0. Remember, those three answers are called the solutions, the roots, the zeros, or the x-intercepts. So you plot those. Here we have a 0, here we have a -6, and here we have our -3. So that is the answer. Remember, these are on the x-axis. That's on the y-axis. That's on the y-axis. When those are y-intercepts, remember, for a y-intercept, there's only one y-intercept, and we go ahead and plug in 0 to get the y-intercept. Okay, we just got done doing that on your test. And this one has 0, +3, and +6. So the signs were opposite on those ones. Okay, you're going to have a problem like this on the DCAS. Okay, this is why we're doing this, so I can practice DCAS. Parent function of f of x is the f of x equals x squared, or in this case, p of x equals x squared. Then the graph of the function, this, where k is greater than 0, so such as 2, if you just plug it into, do a check. If I saw that, that's obviously called vertex form. We just got done testing on this. You should know this. So I can get my vertex right away. My vertex is 2, 5. Remember, we do the opposite and the same here. Opposite for the x, same for the y when it's written in vertex form. So in this case, that if I had that 2 in there, that'd be shifted right 2 and up 5. Okay, well, since we don't know it's really 2, we're going to say shifted right k and up 5 right there. Okay. If you watch the video on your practice test, you saw a problem just like this, except for it didn't have k, it had numbers in there and you put it in, okay, on your test. This is why I gave it to you, because I knew it was on here. Which expression is equivalent to this? Remember, we do PEMDAS. Take that and raise it to the 3rd power. So I have -4 to the 3rd power is -64. And then I have x squared to the 3rd power. And you got to remember, power to power, you multiply. So it's going to be -64x to the 6th is the answer. Number 3. Okay, remember, if you multiplied, let's say I had -4x times 5x squared. When I just multiply across, I'm not doing a power to power. I do the negative 4 times 5, get negative 20. And I have 1x there and 2 there, and I add my exponents. 1 plus 2 is 3. We did this at the beginning of the year. So that's the difference between multiplying with like bases versus a power to a power. This is called you multiply your exponents on the variable. Okay, which function has the smallest y-intercept? We know to get the y-intercept, x equals 0. Plug it in. If x equals 0, you get negative 6. If x equals 0 there, you get negative 2. If x equals 0, you have negative 2 right there. We can see it right there. And on this one, if x equals 0, I get 1. So the smallest one is negative 6 right there. Remember, whenever they ask for the y-intercept, you plug 0 in for the x every time to all the x's or wherever the equation is. Okay, next. Which domain would be the most appropriate use for a function that compares the numbers of emails sent? Well, I can only send full emails. So that would have to be whole numbers. I can't send rational numbers, those are fractions. I can't send irrational numbers or square roots. I can't do that. Integers, that means I can send negative emails. You can't do that either. Whole numbers. So it's again, that's testing the number system. You know what each one stands for, and you're going to have a problem like that. Again, this is a good general idea of a practice DCAS. It's the second one now. You need to memorize all these right here. Let me go through. Eric deposits $500 in a bank. It pays 3.5% interest. So the one represents 100% interest plus 1, 2 places to the left to change it to decimal, 0.035, and then to the year. Sometimes I put Y, sometimes I use N for years. Okay, but when I'm doing interest, okay, whenever you think about interest, it's always going to be an exponential. Notice our variable is in the exponent, which is why it's called an exponential. It's not an absolute value. Remember, an absolute value graph is just a V. It has nothing to do with money at all. Linear, it's only going up. It's going up the exact same amount each year. This is not going up the same amount each year. And quadratic is not a quadratic. The exponent is not 2. It's y. Okay. Given the sequence, when you're using the arithmetic sequence, remember arithmetic means you're adding or subtracting from one to the other. I'm adding 3 each time. That's called the common ratio or common difference. That's my D right there, plus 3. It says which variable would be replaced with the number 3. I found that common difference of 3, and that's what the D is, the common difference. D would be my answer right there. Remember, A sub n is the current term. A sub 1 means the first term. That's why it's a sub 1. Okay, this is current term. You got to remember this. And then if you had it in the recursive formula, remember we had A sub n minus 1. That means the previous term. A sub n being the current term, and A sub n minus 1 being the previous term. We'll look at one of those probably another time in this, like you had it in the first DCAS practice one. We'll see if there's one here later. Okay, here we have 2 representations of data. This nicely is in numerical order. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So number 5 is the middle one. 1, 2, 3, 4, 5. So that's Q sub 2, which is my median. Okay, and I take 1, 2, 3, 4 below. There's 2 in the middle. And since there's an even number of 4, I take the 2 in the middle, which is 5 and 5. So Q sub 1 equals also 5. It's still the same number, but it's really in between those two. And I have 4 up here. I do the 2 middle ones. So that one's going to be 7.5. And that's going to be Q sub 3. Okay, so Q sub 1, 2, and 3. And then that's Q sub 4. And that's Q sub 0, the initial. Okay, which statement about A and B is true? There's A, there's B. Which is true? Is the median of A greater? The median of A was 6. The median of B is 6. They're the same, not greater. The range, remember range means high minus low. The range of A is 9 minus 2 is 7. Is 7 less than the range of B, which is 10 minus 4, which is 6? Is 7 less than 6? No. The upper quartile. The upper quartile of A is, the upper quartile right there is 7.5. The upper quartile of B is 9. Okay. And lastly, we have the lower quartile of A, which is 5 is greater than the lower quartile of B, which is 5. No, they're the same. Okay. Upper quartile of A, 7.5, is less than the upper quartile of B, which is 9. That is true. Okay. Here, which system has the same solution as the system below? So I have this system. I'm going to go ahead and multiply the top equation by 2. So I get 2x there and a minus 2x. So we'll cancel that one out. And then I have 6y minus 2y is 4y. And then 20 plus 4 is 24. Divide each by 4 and I get x equal, or y equals 6. Plug that back in. Solve for, I plugged it back into the first one and get x equals negative 8. So now I go through and remember this negative 8 comma 6 must be true for both equations. So here I have negative 8 is positive 8 plus 6 is 14. True. Negative 16 plus 12. Hold on, let's make sure I do this right. Y is 6, that's 12, or 18, so negative 8, x is negative 8, yes. Okay, so this would be negative 16 and, oh, sorry, not 12, I did 6 plus 6. 6 times 6, 36. And 36 minus 16 is 20. True. Okay, and the others, at least one of the equations is wrong, didn't come out. All right, here's our recursive formula here. Given the pattern, okay, write a recursive formula. So first off, those two are not recursive. Those are called explicit formulas. So you got to remember a recursive formula has the a sub 1 and it has an a sub n minus 1 involved in it. So it can only be 3 or 4 to begin with. A sub 1 is my first term. Notice right there, I have 3 blocks there. So the only one that works right there is a sub 1 is 3. It's number 3 says a sub 1 is 2. So that was real quick to wipe those out right there. Okay, as long as you know what a recursive formula looks like and what the a sub 1 stands for. Students were asked to write the expression which had a leading coefficient of 3. Remember, we have to put it in standard form first to find the leading coefficient and leading term. Our standard form is from highest degree down. Okay, none of these are written in highest degree down. So they're wanting to check to see if you understand how to put terms or a polynomial in standard form first. So I look at the highest degree of each one. There's the highest degree there. Is that leading coefficient 3? No, it's negative 2. Here's the highest degree there. Is that leading coefficient negative 3? Yes, it is. So that's still in play. We wipe that one out. This one, is that leading coefficient negative 3? No, it's positive 3. Here, this one, is that leading coefficient positive 3? I mean, negative 3? No. Oh, leading coefficient of, wait a second, leading coefficient of 3, positive 3. So that one wipes that one out too. That's negative 3. So these two both have leading coefficients of positive 3. Okay, and a constant term of negative 4. Well, that constant term right there is positive 4. Here's the negative 4 right there for our constant term. So the answer is 4. Sarah travels on her bicycle at a speed of 22.7 kilometers per hour. What is Sarah's approximate kilometers per minute? Well, on the DCAS, they have the formula sheet, and there's 1.6 kilometers equals 1 mile. So I need to go ahead and multiply this by 1.6. So if I do that, 22.7. Let's go back again. I guess see if he's going to do it. Okay, let's change that. Come back to it. Start. Oops. Let's hang that up. Let's go back to hitting that right there. There we go. Now it should work. What? All right, let's close this out and bring it back on. All right. Do I say change to cancel? All right, so if we did 22.7 times 1.6, oops, change it to that, times the 22.7. You get that answer. Okay, and then since it's by minute, this is an hour, so we have to divide by 60 after that. Change it to minutes, and that's going to be whatever that decimal is, comes out to be. Okay, so I have 22.7 times 1.6. Okay. It's going to be, I think it's going to be around 0.6 if you did that. Okay, I don't have a calculator, so I just estimated in my head. But you'd have a calculator for that to do that, just so you know. Which order pair does not fall on the line formed by the other three? So the easiest way to do that would be to plot those 4 points and see which one is not lined up. Okay, it's going to, 3 of them are going to be in a line, the 4th one will not. So just plot those. You're going to have graph paper to do that. Go ahead and do that. Solve algebraically for y. Okay, distributive property. I get 4y minus 12 less than or equal to 8y plus 4. Okay, move the smaller to the bigger side. So that's going to subtract the 4y across. That's going to leave me with 4y. Subtract the 4 across. It's going to be negative 16. Y is greater than or equal to negative 4 after I divide by 4. Remember, if you choose not to have the quantity positive on the coefficient, you divide by negative to get your y. You have to switch the inequality sign. That's why I teach you not to do that. Okay, so that would be my answer right there. Here, graph this absolute value function. Remember, absolute value functions always graph into a v. Okay. This right here is going to be my slope. It's going to be a 1/2 slope. Okay. This got moved. Okay, that's not the actual graph. Okay. Notice it says to do it from -8 to 0. So if I go ahead and plug -8 into there, I get -4 plus 3 is -1. The absolute value of -1 is +1. So I'd have that right there. Okay. If I do 4, plug in 4, 1/2 of 4 is 2 plus 3 is 5. So, or sorry, I'm plugging in -4. Over here at -4, it's -2 plus 3 is 1. Okay, so notice I get a 1 there. When I have 2 at the same level, that means the midpoint, that vertex right there, is got to be halfway in between. So that means the vertex has to be at -6. So the question is, where along -6 is it? So I plug -6 into there. That's -3 plus 3 is 0. So it's at -6, 0. Okay, and therefore it's going up like this to right there because it's only go to 0. It's from -8 to 0. So there's no errors at the ends of these because it's going from -8 to 0 and stopping. You need to pay attention and look at the domain. Remember, this is called the domain. Remember vocab domain for the x coordinates where they want you to graph, and y is called the range. If they ask you what the range is, all the range. So if they ask for what the range is here, the range would be y is greater than or equal to 0 up to 3. Less than or equal to 3 would be the range. All the y values go from 0 up to 3 tops. Okay, remember, you could also write that in interval notation to be brackets because it includes those 0 to 3 in brackets. This includes that as well. Those mean the same thing. Okay. All right, over here now, factoring. You're going to have one of these like this on the DCAS. Factor this binomial. Remember, we have a binomial. We're looking at difference of squares. First, I'd factor out a GCF. There is no GCF. So now I'm going to do difference of squares. Is that a perfect square? Yes, it is. What's the square root? X squared. So I have x squared and x squared. Is 16 a perfect square? Yes, it is. 4. And then 1 is plus and 1's minus. Well, you might think you're done, but you're not. This is as far as we've ever done. Okay, in class, I kept it simple, but now I have to check again. Do either of these factor again? There is no sum of squares, so that is done, but there is a difference of squares again. That's a perfect square, so it's x and x. And 4 is a perfect square, so that's 2 and 2, and 1's plus and 1's minus. So this is the factored answer, the simplified form all the way down. So you will get one that's going to be factoring one where you have to do a difference of squares twice like this. So be looking for that already. Now, if it was a select all that apply that are equal, if you saw that one, well, that's also a true statement. and then this would be the final true statement. So if it's a select all that apply that are equal, you select both of those, okay? But if it's only asking for the final answer, it's only this one, this very most simplified one. All right, the table below shows height in feet of a hot air balloon and the number of minutes T time the balloon is in the air. Here's the function. Remember, notice this is in slope-intercept form, so 30.5 is the slope. What is slope? Slope is changing y over changing x. What are the y coordinates? The y coordinates are the height, always. Time is always x. Just so you know, time would always be on the x-axis. Time's never going to be on the y-axis. So if I do change in y, here's my y represents feet. That's why I have feet right here. Change in x, that's time, which is the minutes. So it's feet divided by minutes. And here's my slope, 30.5. So what it's happening here, explaining the meaning of the slope. It means it's rising 30.5 feet per minute. Remember, this means per. Division bar means per. Remember, every time we looked at that in one of the first questions, whenever you see something per something, that's automatically slope. So here we see it right here, 30.5 feet per minute. So that's how much the hot air balloon is rising per minute. Explain to me in the y-intercept in the context of the problem. The y-intercept is the initial height. So it's 8.7 feet off the ground to begin with. Remember, the y-intercept is always the initial height or initial value. Same thing. In this case, initial height. Okay. So 8.7 feet above the ground is when it started before it was let go. All right. Mike knows that 3.3, 6.5, and 4, 17.55 are points on the graph of an exponential function. Exponential function is in the form a, b to the x. And he wants to find another point on it. First, he substitutes 6.5 in and 17.5 in, 5 to get 11.5. Okay, this is not going to be correct. What you do, okay, x coordinate, y coordinate. F of x is the same as the y, so you can rewrite it like this. So I'll be putting 3 in here for the x, 6.5 over here for the y. Then I would do that again for the x. 7.55 equals a, b to the fourth. First one was 6.5 equals a, b cubed. Well, notice a is the same, so they're going to cancel out. Okay. What I can do is I can just divide straight down. So if I put it in the reverse order, put the 7.55 equals a, b to the fourth. Okay, I just put the highest exponent on the top. I can actually divide for that and do a division. Well, the a's cancel out, and then b to the fourth divided by b to the cubed is just b itself. Okay. And then I'd have 17.55 divided by 6.5. That would be what b equals, whatever that is. It's not quite 3, it's 2 point something. 2 would be 13. You got 4.55 or 6.5, which is close to 2/3. So it'd be up somewhere around 2.6 without using a calculator. Okay, that's what b would get. Okay, and then I'd be able to plug that into the b right there. Okay, and I already have b. Then I can plug one of those numbers back in and solve for the a, if I really want to get a. But anyway, what he did here, no. Use methods of completing the square to determine the vertex. So we just got done talking about completing the square. I showed you one on the first DCAS. So I have x squared minus 14x plus blank. That's going to be my c. Okay, that's give me the square, and then I have minus 15, and then since I added a number here, I have to subtract that number since I'm keeping it on the same side of the equal sign. If I was moving across the other side of the equal sign, I'd have plus blank over there, but I'm keeping it on the same side, so if I add a number, I have to subtract that same number so I don't change it. And remember, how do I get this? It's always 1/2 of b squared. So what is half of negative 14? Negative 7. Don't forget the sign with it. So negative 7 squared is 49. This is always going to be a positive number because you're squaring it. So I need to subtract the 49 there. Then this is going to factor into x. I just drop this down, minus 7 squared, and then minus 64. I put those two together. So the vertex, therefore, is opposite same. So the vertex is 7, negative 64. State the coordinates of the vertex. We just did right there, 7, negative 64 through completing the square. Okay, we just went over that last class after your test. You have this video to watch again. You have the other video that I showed you that whole unit already. All right, the temperature, this is the Celsius degrees formula with Fahrenheit involved. They want you to solve for F. So remember, I solve all equations by reverse PEMDAS. Since I'm solving for a variable, I go up. Is there anything to add or subtract across? No, because that says 5/9 times the quantity F minus 32. So now I multiply and divide. Multiply by the reciprocal, 9/5 on both sides. So now I'm left with just F minus 32 equals 9/5 C. And my last step would be to add that 32 across. So F equals 9/5 C plus 32. And there's my formula solved for F. You will have an equation, some problem that they're going to give you. We're going to actually solve, remember this is called solving literal equations. Okay, but reverse PEMDAS, solve all equations. Okay, solve this one, this quadratic algebraically. Notice it's already in standard form. And it says to the nearest hundredth, so that means you're going to be able to put in a calculator. So I could divide each one by 4 to get smaller. Okay, and I'm left with W squared plus 3W minus 11 equals 0. Okay, now you don't have to. You could just type in it. So I'm going to type the left side of the equation into y sub 1 on your graphing calculator. The right side of the equation into y sub 2 in your calculator. And then I'm going to do second calc. And then go down to number 5, intersect. Okay, and then hit enter, enter, enter. It'll give you where it intersects. And you want the x value. Okay, you want the x value of that intersection point, not the y value, and you're going to round it to the nearest hundredth. Okay, so this is a calculator problem. Okay, next one. Linear regression equation and correlation coefficient. Okay, let's see if I can get it to work this time. What the heck? Let's try it again here. See if it'll work this time. There we go. Okay, graphing calculator. Go back, graphing calculator, come on. Start. Go down, start. Remember this is where your graphing calculator is going to be on the DCAS, right there in the middle. Clear it. Remember to turn the diagnostic on for the correlation coefficient. We hit second 0, then go down and hit the D, which is matrix. Scroll down to diagnostic on. Remember, it's not going to be on to begin with. Hit enter, enter twice. Now it's on. Stat, we put in and stat, and then enter the x coordinates in L sub 1, y coordinates in L sub 2. So if I go ahead and look at it, 0, 10, 15, 20, and 30. 0, 10, 15, 20, and 30. Over to L sub 2, do my y coordinates. 68, 84, 104. 68, 84, 104. And what are the last two? 100 and 120. 100 and 120. Okay, then I hit stat, go over to calc, and we want linear regression, number 4, or you can scroll down. Enter, enter, enter all the way through, and it kicks it out. So my answer would be y equals 1.72x plus 69.4. That would be the linear regression line. And then my correlation coefficient to the nearest hundredth would be 0.97, rounding that to the nearest hundredth. Okay, and that's what I put in for my answer. Okay. This is 0.97. That means the correlation coefficient is a strong positive, which means the values, the points themselves are almost in a line. Not quite, but almost perfectly lined up. Okay, 34. Hannah went to school to buy supplies and spent $16. She bought 4 more pencils than pens. Okay, 4 more pencils than pens. So pens, see if X represents the number of pens. So pens equals X. Pencils, what does it say about the pencils again? She bought how many more? 4 more pencils. So then pens, so that's going to be X plus 4. And erasers, what did it say about erasers? It says 2 fewer erasers than pens. So that's X minus 2. It says write an equation in terms of X that can be used to find out how many she bought of each. Well, each pen costs $1.25. So 125 times X plus each pencil 55 cents. So how many of those did she buy? X plus 4. And each eraser is 75 cents, 0.75. And how many did she buy those? X minus 2. And the total amount she spent was $16. So there's your equation. And then it says to solve that algebraically to find out how many pens, which is the X value. So I would go ahead and distribute there. I have 1.25 plus the 75X is $2, 255 X plus that's $2.20, and that's minus $1.50 equals $16. 250 minus, or 220 minus 150 is 70 cents. So I'm going to subtract that 70 cents across, which means me 1530 equals 255. Put X, divide by the 255, and you get 6. Okay, exactly. So X equals 6, and that's X is the pens. So that's how many pens we want. All right, next here, graph the system of inequalities on the axis below. Remember, this is a slope-intercept form. First one, so m equals negative 3/4, my slope, down 3, right 4. My y-intercept is 0, 5. Remember, you always plug in 0 for the x, it gives you the y. So 0, 5, and down 3, right 4. 1, 2, 3, 1, 2, 3, 4. And it's a solid line because it's got an equals to. Second one, I could solve easily for y. Go ahead and subtract or add the 2y across and subtract the 4 across. So I have 2y equals 3x minus 4. Last step, divide each term by 2. And so now I have my m equals 3/2, up 3, right 2. And y-intercept is 0, negative 2. 0, negative 2, go up 3, right 2. Up 3, right 2. And this one is a dashed line because there's no equal sign right there. So dashed, you're going to have to choose that. Okay. This says below. So it's got to be either down here or down here. It's below that line. This one also says below, which means here or here. So which region has 2 dots in it? This region right here has 2 dots. Okay, so there's my answer to that right there. Is 6-3 a solution? So I go back up, look at 6-3. 1, 2, 3, 4, 5, 6. 1, 2, 3, right there. Is that a solution? No, it's not. It's not in the region. Now here's another thing to remember. If the point is on the line right there, if it lands on that dashed line, it is not in the region. It has to be, it can be on the solid line, that's in the region. You know, so if it was right in here, that's in the region. If it was here, anywhere along this dashed line, that is not in the region. So remember that. Only solid counts as being in the region. Okay, 36. You're going to have one of these guaranteed on the DCAS also. Okay, state the height of the platform in feet. That's the initial height. That's always my B. So 112 feet. State the coordinates of the vertex. Okay, now we get that. Remember, you can do negative B over 2A to get the x coordinate. Okay, x coordinate is negative B over 2A. So that's going to be negative 96 over negative 32, which equals 3. So it's 3 comma something. Now I just plug the 3 into here and here and solve that, and that's my y coordinate. So 3 squared is 9 times negative 16 is negative 144. Plus 96 times 3 is 270 plus 18 is 288. plus 112. So 288 minus 144 is 144, plus 112 is 266. Okay, explain what it means in the context of the problem. The maximum height of this projected ball that's shot into the air. Okay, it starts at 112 feet right there. It's shot into the air like this and comes down at 3 seconds. The maximum height is going to be 266 feet. So the maximum height is the y coordinate, and the time it took is 3 seconds. Okay, that's our coordinates for the time. Okay, state the entire interval where the ball's height is decreasing. Well, you should know it's increasing from 0 to 3, and that's decreasing after 3 down to when it hits 0. So we need actually, so we know it's after 3, so parentheses for 3, and then we have to find when it's going to hit the ground. Okay, so I need to set this equal to 0 and solve. Well, one way of doing that is going ahead and dividing each term by negative 16, because they all divide by negative 16 evenly. And I get t squared minus 6t minus 7 equals 0. Well, now that's a nice easy factoring problem. That's going to factor into t minus 7 and t plus 1 equals 0. Well, t can't equal negative 1. That's negative 1 second. But t can certainly equal 7 seconds. So this is when it hit the ground at 7 seconds. Right there. So therefore decreasing, okay, once it leaves 3 and goes until it hits 7 seconds. That's the interval, okay, along the x-axis. Now I could have also plugged that in the graphing calculator just so you know. So if I bring up the graphing calculator, go to y equals, okay, get that out of there, and I have negative x squared, what was it again? Negative 16x squared, sorry, negative, I'll just clear it. Let's just delete this out. Delete it. Negative 16x squared. Was it minus 60, minus 96 plus 96x plus 112 plus 96x plus 112. Second one, I want when the height's 0. Then I'm going to do that second calc, number 5, intersect. Okay, there's my negative 1 second. First curve, second curve, my guess. I'm going to move it closer to that one. I can't have negative seconds. I need that one right there. And there you see 7, 0, so 7 seconds. Now I could also use this to find the maximum height. I'm going to zoom out. Okay, when zoom out. Okay, notice I still don't have it. It's way up there. Okay, I could zoom out again. Move it up again. I'm still not there. Well, I did have the vertex. I calculated with it negative b over 2a. Okay, I could zoom out again. Now I can see that maximum top right in there. So now I do second calc, maximum, left bound, I put it to the left. Okay, enter, put it to the right, enter, guess, put it back there. 256, so I was off by 10, I said 266, should have been 256. I did a calculation error right there. Let's see, 388, 144. Oh yeah, that's 256. I did all that right and made the last basic error right there, 256. Okay, and there we saw in the graphing calculator. Okay, at a local garden shop, the price of plants includes the sales tax. The cost of 4 large plants, so 4L plus 8 medium equals $40. The cost of 5 large and 2 medium equals $28. Notice we have a system of equations. Okay, write a system of equations. There it is right there. Okay, no guess and check method. They want to see the system of equations. Now I go ahead and solve that. I can go ahead and multiply this by -4, because that'll give me a -8m plus the 8m is 0. So I have -20 plus 6 plus 4 is -16L. And here I have -112 plus 40 is -72. 72 and 40, 112, yeah. No, must be 4, 8, and 32 is -112 and 40. 72 and -72. -20 plus 4 is -16. Oh, could the cost of one large plant be $550? So that's actually 4, that's 64.50 is for a large plant. You get 450 for a large plant. So could the cost of one large plant be 550? No, it can't. Large plant's 450 when we solve that. Determine algebraically both the cost of a large plant and the cost of medium. So I already did the large plant, 450. I would plug that into, let's just say the first one right here, 4 times 450 is 69 plus 2 is $18 plus 8m equals 40. Subtract the 18 across. I get 22. Divide by 8. And that's 2. And that's 16. That's 6 left. 6 eighths is 75. 3/4. 275 for a medium. Okay. They probably have a calculator for you to do this on this. I'm just using my brain. But that'd probably be a calculator problem, calculator section of that. All right, that does it. So that gives you an idea. There's probably close to 30 something problems on the DCAS itself. It's over 2 days, Thursday and Friday. And if you can do all these types of problems, you should be able to pass the DCAS. Because remember, to pass the DCAS, you only need 50% to pass. If you can do most of what we just did right here, you should be able to pass the DCAS.